Welcome to EDU World Space.
All right, so for number 35, I'm going to utilize the graphing calculator to be able to plug in my equation and determine the horizontal distance, which is our maximum x, and then the maximum height for part B is our y of our vertex. So we're going to start by plugging in this equation. So we have h of x parentheses is equal to negative 0.026x squared plus 0.576 x plus 3. And so with Desmos.com, I can zoom out and see everything I need to see and zoom in with what I need. So this is representing a fire hose starting here at the height of 3. And then this right here is our maximum distance and height. And then this is where it lands. So this is kind of the picture that we only really care about is the positives, because if you're thinking about a fire hose, it can't be over here on the left and it can't go below this x-axis. So for part A, it talks about at what horizontal distance from the point of launch does the maximum height occur around to 2 decimal places. Well, this is the maximum height, so it'll be at 11.08 if it says to round to 2 decimal places. So, or 1 decimal place, I apologize. So 11.1 will round up here. So 11.1 meters, I believe. Yep, in meters. And then for part B, it says what is the maximum height of the water? Round to 1 decimal place. So this 6.19 will round to 6.2 meters. So that's our maximum height of the water. And then C, it says the flow of water hits the house on the downward branch, so going downward, when the height is 6 feet. So what is our nearest meter? So if I want our height to be 6 feet, I simply type in y equals 6. And notice it hits it at 2 spots. But since it's at the downward one and round to the nearest whole meter, this 14, this will round to 14, is what we want. If it was saying something about upward, then we would want the 8 meters. But this case, we want the 14 meters. So that's your answer for part C.